So hello everyone, welcome back to CodeSpide. Here in today's video we are going to learn one of the most important Java concepts that every Java developer and interview candidates should know. So the topic is how Java works internally. So have you ever wondered what happens after you write a Java program and click run? How does Java achieve its famous slogan that's write once and run anywhere? What exactly are JDK, JRE, JVM, bytecode, class loader, JIT compiler and garbage collector? Don't worry, by the end of this video you will understand the complete Java execution process from source code to output in a very simple and interview oriented way. So without wasting time, so let's get started. So the first topic is what happens when we write a Java program. Suppose we write the Java program, that is that public class hello world, public static void main, system out println hello CodeSpide. So many beginners think that Java directly executes this code. Many beginners, this is the thoughts, but that's not how Java works. Java follows several steps before displaying the output. The complete execution flow look like this. Java first approach is that Java source code, we write the Java source code, then after developing the source code, then it directly pass to the compiler and the compiler compile the source code. After compiling the source code, it will generate the intermediate code that is called as bytecode, and that bytecode will execute by the JVM. JVM responsible for executing the bytecode, but that bytecode after executing by the JVM, that bytecode again converted into machine code, and that machine code originally going to be executed inside our operating system. That the main procedure, that the inside working principle of the program, or the, if you want to say that working principle of JDK also. The complete process, the complete flow is the starting from our source code to complete output. So let's understand each component one by one. But before understanding JVM, what are JDK and what are JRE? Listen here, many students get confused between JDK, JRE and JVM. So first let's clear that first. What is JDK? JDK stands for Java Development Kit. JDK is used for developing Java application. Okay, JDK is responsible for developing the entire Java application. It contains JRE, Java compiler, debugging tool, libraries, development utility. All these things are simply combined within the JDK. So simply if you want to remember, you can remember JDK equals to JRE plus development tools. Coming to the JRE. JRE stands for Java Runtime Environment. JRE provides the environment required to run Java program. It contains, means JRE contains JVM plus some libraries, and also it contains some supporting files also. Here you can see core Java with some libraries. So simply if you want to remember about the JRE, the JRE equals to JVM plus some libraries. Here also a important point is there, that is without JRE, Java program cannot run. Next component, the middle component, if you want to say that is the main core component, the heart of Java is known as JVM. Here JVM stands for Java Virtual Machine. It is the heart of Java. It is the actual heart of Java. The main working of the JVM is to load class file. Next one is verify bytecode, allocate memory, execute programs, manage garbage collection. So without JVM, Java applications cannot execute. Like in JDK and JRE, here also without JVM, Java applications cannot execute. Before going to the source code, here is the complete difference between JDK, JRE and JVM. Here the complete difference means JDK stands for Java Development Kit, JRE Java Runtime Environment, JVM Java Virtual Machine. Primary role of JDK is to develop our entire code, and the JRE is responsible for execution environment, and the JVM is responsible for execution engine. So JDK is required for writing and compiling the code. Then JRE is required for running the programs. And lastly, but not the least, JVM required for executing the bytecode. Okay, so moving to our first step, that is the source code. When we write Java code and save it as, so it's look like this hello world.java. You can also save in any other names, no problem. This is called the source code. This complete or this entire code is called as the source code, which is also human readable format. Source code is understandable by humans. However, computer only understand machine language. Therefore, Java source code must be converted before execution. Here, as we all know, computers only understand machine language. So, here Java source code must be converted before execution into machine code. So, the next step, that is the Java compiler. What is the main role of Java compiler? Java provides a compiler called Java C. When we execute our source code hello world.java, we need to write the command java c space hello world.java. After entering the command, the compiler performs several checks like syntax checking, type checking, variable validation, method validation. If no error found, the compiler generates hello world.class. This file contains the entire or the complete bytecode. It is the converted format, or you can say that it is the intermediate format of source code. Means converted format, intermediate convert. Why we called it as intermediate? Because this is the main code through which we can execute our program in every system. So this principle, this concept, this bytecode is leads to the platform independency feature. So next one, what is bytecode? Now the entire code is converted into bytecode. So main question is, what is bytecode? Bytecode is an intermediate code generated by the compiler. What are the features? If we want to say that these are the some advantages of bytecode, that's the advantages are, first advantages is platform independent. The bytecode is completely platform independent code. These are the not human readable format and also not machine code. Bytecode only the measure or the advantages is the platform independency feature, because Java generate bytecode instead of OS specific machine code. Because the Java generate bytecode instead of machine code, the same program can run on different operating system. Yes or no? The same program can run in different operating system. This is the secret behind Java portability, Java independency feature. Okay, so actual the bridge between OS environment is the bridge between user and the OS. The actual code is bytecode. So bytecode here responsible for Java portability feature or machine independency feature. Next step is that JVM start execution. How can JVM start execution? When we run Java, when we type this command java hello world, then JVM start working. Its responsibility include loading classes, verifying bytecode, managing memory, executing instruction. These are the main responsibility of JVM. What are the responsibility? Loading class, verifying bytecode, managing memory, executing instruction. So now let's understand the internal component of JVM. First one is class loader. Here what does the main responsibility of class loader? Its job is to load required classes or required class file into memory. First job of class loader is to load required class file into memory. For example, system.out.println, if we write here, it's belong to Java's predefined library. The class loader automatically loads this class when required. Types of class loader, if we say, then there are majorly three types of class loader. First one is bootstrap class loader, another one is platform or extension class loader, next one is application class loader. There are majorly three types of class loader subsystems are there, or class loaders are there. Next component is bytecode verifier. After loading classes, JVM verify the bytecode. Here after loading the class, the JVM verifies the bytecode. So why verification is needed? Why verification is very important here? Because to ensure the security, correctness, low illegal memory access, no corrupted bytecode. This makes Java secure and reliable. This is the main concept behind this bytecode verifier. Verifier means actually scanning the entire code, actually verifying the entire code here. After completion of verification, then the next step is the runtime memory area. Here before execution, Java creates memory area. like method area. It store class metadata, static variable, methods information. Example, static int count equals to 100. If we write here, it store inside the metadata area, means method area. Then if we move to the heap memory, if we say about heap memory is responsible for storing the objects only. Suppose example, if we write student s equals to new student, the object is created inside heap memory. Heap is shared among all threads. The next memory, we say that stack memory. So it can also store local variable, okay, method calls. So if we want to execute any normal variable or local variable, suppose we write int age equals to 25, so it's stored inside only stack memory because there's a local variable. Then if we move to the next step, that is the execution engine. Now the execution engine executes bytecode. It consists of, the execution engine actually consists of interpreter, compiler. So the interpreter, if we say that what is interpreter, the interpreter reads bytecode line by line and execute it. Advantages of the interpreter is to quick startup. Disadvantages are there also. There is a compiler known as JIT compiler. JIT means J stands for just in time compiler. It is used for improve the performance. JVM uses a JIT compiler. If we want to improve the performance, the JVM directly use a JIT compiler. JIT identifies frequently used code and converts it into native machine code. So what are the benefits here? The benefits, we can say that the faster execution, better performance, reduce repeated interpretation, and modern Java application heavily depends on JIT compiler. Modern Java applications, we say that if we want to develop any modern application in Java, then it's directly, or you can say that heavily or by defaultly depends on the JIT compiler only. So these are the main principle of a major execution process inside JVM. Then if we again move to the next step, that is a very important concept. We said that that's the garbage collector. What is garbage collector? Look here, Java automatically manages memory using garbage collection. Example, suppose we write here student s equals to new students, s equals to null, object is now here abandoned. So now the object is no longer referenced. Here the object is no longer referenced, abandoned, because we assigned null into the same reference variable. So garbage collector identifies such unused object and remove them from heap memory. After writing this statement s equals to null, here garbage collector identifies such unused object and remove them from heap memory. So what are the benefits of this garbage collection? The advantages, or we can say that the benefits, are automatic memory management, better performance, reduced memory leaks, and no manual deallocation. So this is one of Java's most powerful feature. So the complete Java execution flow, if we say that here, first write Java program and save with .java file, compile the Java code by using the JavaSeq command. .class bytecode will be generated here after compilation, and after compilation class loader is responsible for loading the class, and after bytecode verifier, runtime memory access is also here needed, means heap memory or stack memory. Here one slide I miss here. This is the memory difference, heap memory versus stack memory. Here if we write here student is equals to new student, means object creation. So object creation, the new student available inside the heap memory and the s is available inside the stack memory. So if we write new student, then it's stored in the heap memory. So heap memory is shared among all the threads. But if we write like int x equals to 10 here, inside stack memory it will store. So it's only accessible to the local scope only, means within a single block. So here one fact you will find in the interview also. So objects are always dynamically allocated in the heap, and while local primitives, variables, and method execution frame stack up sequence in the stack memory. These are different differentiate if we want to create. Then these are the some points you will find in the also interview. Okay, so back to the our original slide. So all these steps are happens within a millisecond only. After runtime memory allocation, means heap memory or stack memory, then execution engine come into the picture, and then after interpreting the code, after generating the actual machine code, it converted into the native machine code or generated the native machine code. Then last question is that why Java is platform independent? Why? What's the main reason behind the platform independency feature? Look here, Java compiler generate bytecode. Here the actual bytecode is here. Okay, so bytecode can run on any JVM. How? We say that the Java is platform independent, but how? How can we say that? How can we prove that this is the platform independency picture is like this. So here bytecode can run any JVM. Like if we use here a Windows system, if we use here a Mac operating system and Linux operating system, everywhere same bytecode if we want to execute in different JVM or in different operating system, then it will completely or it will successfully execute that same bytecode in different operating system, because of the different JVM for different platform, for different OS. For Windows there is a separate JVM, for Mac there is a separate JVM, for Linux there is a separate JVM. For separate environment, separate JVM are available, so that JVM makes Java code or makes that bytecode executable or general process for all the operating system. That's why Java follow write once, run everywhere or run anywhere over principle. So that's how Java work internally, from source code to compiler, bytecode, JVM, class loader, memory area, execution engine, JIT compiler and garbage collector. This is one of the most important interview topic of Java developer. Freshers and experienced professionals also frequently find this type of question. So if you found this video helpful, make sure to like the video, subscribe to CodeSpide and press the bell icon so you never miss any upcoming Java tutorial, coding challenges, interview preparation, videos and project based learning content. Thanks for watching. This is Anubhav from CodeSpide and I will see you in the next video. Thank you.